Okay, so you see it now?
Yes.
All right. So find the t-value such that the area in the right tail is 0.25 with 25 degrees of freedom. So what do you think?
For the t value,
Yeah.
wouldn't we um t stats maybe?
No, the stats are used when you are doing into the hypothesis test or the confidence interval. So if you're not into the hypothesis test or confidence interval, there's something else which you need. So look at what we're talking about. We need a t-value and we are talking about a right tail area. So what does that remind you of?
Um the calculators.
Which one?
So
Yeah, so which one will it be? How many calculators do we use? For
3.
3. And which are those?
The t calculator, normal and chi-square.
Right. So which one will be used here?
The t calculator.
Right. So stats. Do we have stat crunch? Okay, not here. So let's see. Stat crunch. Hmm. Okay. So how do we go there?
Stat calculator, and then the t is kind of towards the bottom.
Okay, and then now what do we do?
Um, it gives us the degrees of freedom. So it would be 25 for that. And then I think it said it was right tail. So we'll have a greater than sign.
Right tail. That's annoying. All right. So right tail would be greater than. Okay, and then
And then the other number we'll put in the area box.
right. So the 0.25 area in the right tail is 0.25. Okay, so 0.684. Okay. Now, how are the critical values done?
With the calculators.
Right. C for critical, C for calculator. So which calculator in this case?
It's talking about the mean.
Hmm?
Would it be the t calculator?
Right. Mean calls for T calculator. And also they tell us here, but they won't always tell in every problem. So mean calls for T calculator. Okay, so now what's the difference between this one and the previous one?
Let's see. This one gives us the sample size,
Right.
and I forget what that little symbol is called.
Which one? Which little symbol? The alpha?
Alpha.
Yeah. That's the first letter of the Greek alphabet.
I know.
Greeks will not be happy if you tell them that you don't even know what this symbol is. Hmm. Okay, so and alpha means what? Where do we put the alpha in the StatCrunch?
Mm, in the area box?
Right. And uh, in the left-tailed and the right-tailed, you just put alpha in the area box. But if it's two-tailed, we do it slightly differently. What do we do then?
We do 1 minus
Right.
the alpha.
1 minus alpha, and then we use the between, right?
Yes.
Because there you have to get two of them. So here, this is left-tailed. So we just do the normal stuff. So the uh, sample size was 15.
So wouldn't we do 1 less?
Right, so be 14. Degrees of freedom 14, and then what else?
We'll put the number they gave us for alpha in the area
Okay,
box.
0.05. And is that all?
And it's left-tailed, so you need to change it to a less than sign.
Right. So negative 1.761. Negative. Okay. Once again, critical. What kind of obsession is this with critical values? Oh, but something is different.
Yeah, we'll use it's two-tailed.
Right, that's one difference. And what's the other
And
one?
we'll it's standard deviation, so we'll use chi-square calculator.
Right. So chi-square calculator. Mm,
And we'll do between since it said it was two-tailed.
right. So stats calculator chi-square, and we do between, and then
And we'll do the 1 minus the alpha.
right. So that would be um 0.9. 1 minus 0.1.
Yes.
0.9, and then this is 26. So 15.379 and 38.885. $38.885. Again, critical values. So
Mm, I don't remember which one this one is.
So what's this symbol called? Well, you don't even know what alpha looks like, so how would you know this one?
Yeah.
This
I
is
remember seeing it, but I don't remember
what?
the name of it. I remember seeing it.
This is chi-squared. This is the chi-squared symbol.
Oh, okay. I need to write that down.
So you know that alpha is the equivalent of A. Do you know what chi-squared is the equivalent of?
Mm, I do
I
not.
think it's K. It's the equivalent
Okay.
of K because gamma is the equivalent of C, beta for B.
Yeah.
So, so then once we know that the symbol is chi-squared,
It's a critical value, so we'll use the chi-square calculator.
right? So, mm,
And we'll go back to standard.
go back to standard. Oh, do we go back to standard? Um, because now they don't give us alpha, they give us a confidence level. Now, when they give the confidence level, where does this go? This 90% confidence.
Doesn't it go in the area box?
But what kind of area is the confidence area? Is it a tail area? No, alpha is the tail area, but confidence is not a tail area. Confidence is some other kind of area.
Um,
Because not only it's important to know that it's the area, but you also have to know area where. So I did remark about this in a couple of videos when we were doing it, that the confidence level is always the in-between area.
okay.
So if it's 90% confidence, then it means the in-between area is 90%. And then what were the degrees of freedom? So 10, so it'd be 9. And then sometimes in these critical values, like in the previous problem, they were just saying that write the two critical values with commas. And over there, it doesn't matter which order you write them. But here, look, they are using particular symbol for a particular box. They have this one, 1 minus alpha by 2, and they have alpha by 2. So they have specific meanings. So that 1 minus alpha by 2 is for the left or the smaller one, and the alpha by 2 is for the right or the bigger one. So here it's very, yeah, and sometimes they change the order. There was one problem I saw uh, in 10.4 where they were asking for the alpha by 2 first and 1 minus alpha by 2 second. So don't just automatically
Yeah.
do it, just watch out in every problem. So in this case, it's the left one first, which is 15.379. Oh, no, that's the previous problem. Oh, so the area was 0.9 for the confidence. Okay, so 3.325 and 16.919. Okay. So finally, something other than critical values. Hmm. Construct a 90% confidence interval for sigma square. So whenever we have to do confidence interval or hypothesis test, what do we do on StatCrunch?
Um,
That's something you said in the very beginning of today,
yeah, we would use, like if it was a proportion, proportion stats,
right?
and for mean, t-stats, and
Mm-hmm.
standard deviation, variance stats.
Okay, so what do we do here?
Um, let's see. Will we use mm, variance stats?
Right? Why?
Um, because it says variance.
Where does it say variance?
It says the sample variance is determined to be.
Not because of that, because even in other problems, they sometimes give you sample standard deviation or sample variance. So it's not this one that is telling us that it's variance stats, but something else that's telling us.
It says that it's known to be normally distributed.
No, that also doesn't tell us that it's
I didn't
variance.
think so, but um,
So you have to look at the question part of the problem. Where are they asking the question?
where it says construct a 90% confidence interval.
Right. For
Um,
what's this symbol for?
standard deviation.
It's no variance. The square is the variance.
Okay.
So that's a symbol for population variance. So it's because of this one that you know it's variance stats, not because of the S square over there. So wherever they say construct the confidence interval, it's over there that you have to look for that what are we doing it for. So now, once we know it's variance stats, let's see, what do we do?
We'll go to stats, variance stats, one sample with summary.
Variance stats, one sample with summary. Okay. So what do we put here?
It it gave us our sample variance.
Mm-hmm.
So let's see in the problem. Mine's 13.4. I can't see.
You can't see mine?
No, sir, because it's at the end of that top statement.
Really? So you can't see the whole screen?
Okay, there it is. 13.3.
Okay. So uh, now how do they sometimes trick us in these problems?
Where we have to square it ourselves.
Right. And then what are they giving us when we have to square it? Then they don't give us the S square. What do they give instead?
Just the S.
Just the S. So then you know that since the box is calling for variance, then you have to square that. But here it's already a square. And
Right.
so n is 20.
Yes.
Sample size is 20. And then what else do we need to? We need to bring it to the confidence. So 90% confidence. So 8.38 and 24.98. Oh, okay. There's one thing I wanted to say in that problem. Okay, so here they said make a 90% confidence interval for sigma square. What if they had said make a 90% confidence interval for sigma?
Um,
First of all, which stats will we use?
mm, wouldn't we still use the same one?
Right, we'll still use variance stats, but then what will change if this was sigma instead of sigma square? There's only one change that will happen at some point. Everything else stays the same. And what is that change that we will do? And actually, that is something which trips a lot of students.
I feel like I remember one of the homework problems being like that,
Mm-hmm.
but I can't remember exactly what we did.
So, okay, think like this. You were using variance stats, right?
Yes.
So variance stats naturally should give you the answer for variance, which it did in this problem because the sigma square is the variance. So the answers you got were for variance. But if you are using variance stats to get the answer for standard deviation, so once you know the variance, how do you find standard deviation?
You square it.
Square it or square root it?
I'm pretty sure you square it.
Mm. If you go from variance to standard deviation, you square root.
Oh, yeah.
If you go from standard deviation to variance, then you square. I think you're confusing it with that thing which we were putting in the area box where if they give us the standard deviation, then we square it to get the variance in the box.
I'm not
But
sure.
here the situation is that variance, the confidence interval that we get by using variance stat is always for variance. So if you are using it to get it for standard deviation, then remember that standard deviation is the square root of variance.
Okay.
Variance is the square of standard deviation, but standard deviation is the square root of variance. So then what will we do?
So will we square root both of the answers
Right.
to get the... Okay.
Okay. So first of all, 101 of 1010 adults stated that they believe too little spending on national defense. Obtain a point estimate. So what's another name for point estimate, which will help you remember what to do in this problem for part A?
Proportion.
Right, it's a sample proportion. So how will we do it? The p hat.
I know the next part we would use proportion stats.
Right, but what about part A?
Not sure if we would.
Yeah, you can't get away from part A just because you have knowledge of part B.
Would we still use proportion stats for that?
No, part A is something which you could have done even 5 years ago. If they told you that it's 101 out of 10 that are saying this, what proportion is saying this? Remember, that's why I asked you what does p hat or point estimate mean, and you said it's proportion. So how do we get the proportion if you know that 101 out of 10 are saying something? Then what proportion is saying it?
Wouldn't we just divide it?
So 101 divided by 10. Is it 0.1? Oh,
Yeah.
0.1. Okay. Now we come to part V. So what did you say? Proportion stats?
Yes.
Okay. Because because they are saying confidence interval for proportion of adults, right?
Right.
Okay, so proportion stats. Proportion stats. One sample summary. Okay, so
It gives us the confidence.
what's the number of successes?
Would it be the p-value?
No.
Oh, would it be the 101 and then the number of observations would be the 1010?
Right. 10. Okay, and we go to confidence and 99. So 0.076 and 0.124. Is it possible that more than 15% of adults believe there is too little spending? Is it likely? More than 15%. Okay, so what is this confidence interval telling us?
That's the lower limit and the upper limit. So in between those?
So it's telling us that we are 99% confident that somewhere between 7.6% and 12.4% adults believe that there is too little spending, right? This is 7.6% and this is 12.4%. So in the whole population, we are 99% confident that somewhere between 7.6% and 12.4% people believe that there is too little spending. So then is it possible that 15% believe that there is too little spending? We're,
Um,
we're saying it has to be between 7.6% and 12.4%.
so it wouldn't be.
It's not possible. We are 99% confident. You're not 100% confident.
I'm confused.
So is it possible to get out of this interval or not?
Uh,
If you say that I'm 99% confident that you are a liar, so is it still possible that I'm not a liar?
yes.
Yeah, because even you are not 100% confident, right? You're saying 99% confidence. So then is it possible that it's 15% even though
It
it
is.
is, but is it likely?
No,
No,
I would say
it's very unlikely, but it's still possible. And then remember that basic rule in statistics that we've been talking about through the whole course, that statisticians love to say that nothing is like 100% sure, right?
right.
We always try to avoid making statements like that, oh, something is impossible or something is like definite. So we won't say that it's impossible, but it's unlikely to go out of this interval. Okay, so which one?
C.
See. And when do we choose B?
Mm, when it's in between the
Right.
7 and
Right. If
12.
it's in between, then of course it's possible and likely because it's falling in between. And then when do we choose A?
Um, will the percent ever be 100%?
No.
Um, I'm not sure because the 15% was out of that range, but it's
Mhm.
still possible.
Yeah. So then can't we say that we will never be picking A?
Yeah, I guess. I don't know.
Yeah, although it seems like interesting that on the one hand, we're saying that you never say never. And then I'm saying that, oh, you never pick choice A. But here
I'm
it's true that we never pick choice A because choice A is saying that it's impossible and nothing is impossible, right?
not-
So yeah, choice A will never be picked. If it's in between, you pick choice B. If it's outside the interval, you pick choice C.
okay.
Okay. Test statistic. So how is the test statistic done?
Mhm. Um, would it be with variant stats?
Um, yeah, you're right. Okay, variance stats, right? Why and why?
Because I looked at part A and it says the sample standard deviation.
Not because of that, because this
Oh,
will be given even in the other kind of stats.
oh, then I don't know.
Look at the hypothesis test.
How about this?
Look at the beginning.
Oh, when it uses that certain symbol, you know which
That's for
one you.
standard deviation, which means it's variance stats, right?
Okay. So we would go to stats, variance stats, one sample with summary.
Okay. And then
Um, and would we square
yeah,
the
that's where we have to square it because the box asks for the square which one?
the 17.9?
17.9 caret 2. Okay, and then sample size is 28. Okay, now what do I put in the hypothesis test?
It's gonna be 20 and less than.
Really? Is it going to be 20?
Yeah.
What, look, what's the box asking for?
We'll square it.
And what is this?
Mm,
That's without the square, right?
right.
So
So we'll square it.
square it. 20 squared is 400. And then it was less than.
And then that's chi-squared symbol. So we'll put the.
So 21.628, 21.63.
And it gave us the p-value.
Right, p-value was 0.244. Okay, what's the conclusion?
Aren't we comparing the p-value to the
To the what you don't know what it's called.
alpha?
Right, good. So what's the
Um,
verdict then?
when we're comparing it, will we rate it as 2.44 or
No,
0.244?
we just treat it the way it is, 0.244.
Okay. So it would be greater.
Right, so P is greater than alpha. So what happens if P is greater than alpha? What was our main criteria of the rejection and not rejection in terms of P and alpha? And that's a criteria without which you could not have survived up to this point. So I'm sure you know it.
Yeah, because I remember doing the homework, and when it was in like the rejection
Yeah,
area.
so that's another criteria which we use, that if you see that the test statistic is in the rejection region. But what is the criteria in terms of P and alpha?
You know.
That's a criteria which is used in all the three situations, whether you are uh, testing the proportions or means or standard deviation. There's a standard criterion in terms of P and alpha.
Um,
And I think you do at least 15 problems in the chapter using that criterion. So,
if
you,
it's greater, you
I mean, you're being very vague. What's greater? So if P is greater than alpha, then what do you do?
you will reject it.
No, then you don't reject.
Okay.
If P is less than alpha, then you reject. So here you would
Oh,
not reject.
let's see.
Okay. So,
Okay. So this one is with data.
right.
Um, and we're going to use mean.
Mm-hmm.
So it would be t-stat.
Mm-hmm. So open in StatCrunch.
So stats, t-stats, one sample with data. Gives us confidence.
You select the column and then 95% confidence and compute. So 154.8 and 177.2. Am I using the correct number of decimal places?
It says round to 2 decimal places.
So am I wrong? Am I wrong or am I right in what I've written?
You only have to 1 decimal place, so you need to do one more
Really?
because it's rounded to.
But weren't some alarm bells ringing when I asked you a question like this? Because have I ever asked you a question like this before? So, so now look at what the answer was and look at, where is it, by the way? It's gone somewhere. So, okay, the reason was that this was 8-0 and this was 2-0. So
Oh,
so that's why in that case, if you skip it's okay. All right.
Okay. Um, would we use t-stats?
Why are you so hesitant?
Because I wasn't 100% sure. But it just says test statistic and then t-distribution.
Right, and actually it's from here.
Oh, and the symbol.
Symbol for the mean, right?
Okay, yeah.
So that also calls for t-stats. Okay.
I forgot to look for that.
Mhm.
Okay, so
So,
stats, t-stats, one sample with summary.
okay.
And the X bar would be the sample mean.
All right, 47.6. And
And then our standard deviation is given as well, the 11.3.
the size,
That'll be the N,
22.
the N equals.
And then equals to 50 and less than 50. Negative 0.996. Okay, part B.
Um, we'll use the T calculator.
Mm-hmm. So T calculator. Oh God, I don't know where that window is. We may need the P value at some point, but okay. Hmm. So stats calculator T. Okay, and then what do I put in it?
Um, the the alpha would go in the area box,
Okay, 0.1.
but I'm not sure what would go.
In which box?
In the top one.
The degrees of freedom?
Yeah.
Or isn't it n minus 1?
Oh, yeah.
What happened? You've told this about 6 times today,
Who knows?
and the seventh time you forgot.
Yeah, that's crazy.
Hmm.
Um, and we would do, wouldn't we do less than?
Yeah, because this is less than.
But yeah.
Negative 1.323. Okay, which graph is it?
Wouldn't it be this last one? C?
No, it's left tail. Okay. And now, how do we decide about the rejection?
I don't know why, but I can never remember about the rejection. Like, even going to the homework, I couldn't remember.
Which criterion do you like? The P alpha criteria, or like the when you look at whether it's in the critical region or not? We'll just take your choice.
I'm not sure. Can we go over both of them again?
Okay. So where do I find the p-value of this stupid thing? I mean, there are 10 windows open right now. Hmm, how do I know where it is? So this is only one. So if we close this one, then
I need to write this down.
okay, if we close this one and close this one. Oh, okay. So let's see. Developer 7 hidden results. T calculator. So is it this? So is it this problem where it was negative 0.996? So I think it's this. The p value is 0.1652.
Okay.
So I think it was this. So p. So remember, p is 0.1652. Yeah, it is this problem. So 0.1652, is it less than alpha? Point 0.1652.
Less than this alpha, that's 0.1.
Yeah, is it less than this alpha?
No.
No. So if p is greater than alpha, then do we reject or do we not reject?
You will not?
You will not reject. If it's greater, then you don't reject. If it's less than alpha, then you reject.
Okay.
Okay, so we already, with this knowledge, we can answer. So the question was, will the researcher reject a null? So tell me, which one will it be?
Mm, would it be A?
No, because it does not fall in the critical region, right? Because when you reject, then it falls in the critical region. So now, if you, instead of using the P alpha criterion, if you were to use the other one, so let's go. So if you were to use the other criterion, so then what you do is you look at the graph, you already have the graph in the problem and you know that this was the correct one. So this cutoff value is the critical value, the negative T alpha here. So what was the critical value in our problem? It was negative 1.3, right? So it means this value over here where the region starts is negative 1.3. Now you look at what the test statistic was. It was negative 0.99. So will the negative 0.99 be in this blue region or not? Remember, this is negative 1.3. So will the negative 0.99 be here or outside? Just think of it as the number line where this is negative 1.3. So where is negative 0.99?
But if that's negative 0.3, then it would be in that region, the way I'm thinking.
No, that's negative 1.3, right?
Mhm.
So you are telling me negative 0.99 will be on the left of negative 1.3? Draw the number line and see if you are happy with what you just said. You're telling me that negative 0.99 sits on the left of negative 1.3 on the number line?
Okay. No, it would be on
The right, yeah.
the right.
And because if it's less negative, then it's on the right.
Okay.
Negative 1.3 is a bigger negative number, so it's on to the left, and the negative 0.99 is a smaller negative number, so it's on the right of it. So it is outside. So if the test statistic falls outside, then it's do not reject.
Mm.
Okay.
So if I'm looking at my critical value, it's
In the previous
negative.
problem? Okay, so what were your values?
My critical value was negative 1.7.
Okay, so it means that now this is negative 1.7 here. And what was your test statistic?
Negative 1.1.
So if this is negative 1.7, where will negative 1.1 be?
Wouldn't it be in the rejection area?
You're telling me negative 1.1 is the...
I don't know why this is so confusing to me.
No, number line. Come on, this is number line we're
I
talking about.
know.
I thought American students are such experts in number line.
Not this one, apparently.
You're a non-typical American if you are not comfortable with number
I
line.
don't know where I came from, but I can't get this.
So let me quickly review number line for you. Okay. So, Okay. So where's my stylus pen? Okay, draw. Okay. So you agree you have 0 in the middle?
Yes.
And then let's go by your critical values. It was negative 1.7, right?
Yes.
So let's say um, let's say this is negative 2. And so do you agree that it would be looking like this, that you have negative 1,
Yes.
negative 2, and then negative 1.7 will be somewhere here? I mean,
Right.
I've drawn it too much in the middle, but you agree that negative 1.7 will be somewhere in between negative 1 and negative 2, right?
Right.
Negative 1.7. Okay. And now we want to see where the negative 1.1 will be. So tell me in this picture. So this was the critical region, right? This was the shaded region. Agreed?
Right.
So now in this picture, tell me where will negative 1.1 be? Will it be in here or will it be close to this negative 1?
It would be close to the -1.
Right, so it's outside because 1.7 is further away. 1.1 is closer to it.
Okay.
So the negative 1.1 will be here.
So it should be just not. Okay.
Okay.
Um. Would we use well,
Well, first we just have to write down the test here. So what do I pick?
would it be the sign that we use for T-stats?
You don't want to name the Greek letters.
The top one?
This one?
Yes.
Why?
Um, I don't know.
Um, why did you say that? You didn't
That's what I think it is, but I'm
know.
probably wrong
There got to be a reason behind the thinking. See here,
because
you're not giving, yeah, why?
the statistic
Test
and
statistic is asked in all the three, whether you are using the means, proportions, or standard deviation. You always are asked the test statistic problem, so that doesn't tell you that it's that.
mm,
So you look at what is being investigated. So what are you trying to investigate?
the mean wait time.
Mean wait time. So what's the keyword?
Mean.
Mean. So mean, and that's the symbol for mean, right? Okay. And then
Um, The first one's always the equal sign.
Okay. Mm-hmm.
And then would you figure out the second one by reading like the main problem?
Right. That what are you trying to investigate or what are you trying to prove?
Okay, mine says decrease wait time.
Mm-hmm. Yeah, she believes that it will decrease the wait time. So which one then?
Wouldn't it be less than?
Mm-hmm. Okay, and now?
We would use t-stats with data.
Right. Why t-stats?
Because we're trying to figure out the mean wait time.
Good, good. Okay, so copy. Stats, t-stats, on sample data. So you select the column and then is that it? You just select the column and you're done?
No, we'll put in the hypothesis as well,
Okay.
and it gave us the 80. Well, let's see, the 85.9, and then we'll do the less than sign.
Mm-hmm. Okay. Negative 1.574. Oh, it has had the p value on it. Okay. 0.0749 for the p. So what's the conclusion? P is 0.0749 and alpha is 0.01.
Alpha was 0.01.
Mm-hmm.
It would be greater.
Right. So
You will not
no.
reject.
So which choice?
Um. Okay, so would it be D?
Uh-huh. Because when you don't reject, then you don't have evidence. Okay. I just thought about a Greek saying that, okay, oh, this is the letter that you use when you have proportions. Okay. So what do I pick?
Um, oh, that one's equals.
Okay. And what value goes there? What are we investigating?
If they'll have enough money in retirement.
Yeah, that's a question, but you are skipping the main word, which will tell you what number goes there. What's the key word in the problem?
They surveyed.
Right. Survey is not the key word. You always survey. But you are surveying something very special this time. What are we trying to find? Now, you said the qualitative part, that whether they have enough money or not, but what's the numerical part of the problem?
Let me go to that one.
There's one word which is so important. And that word will tell you what number goes in there. That's an English word, but that English word which will help you in deciding what number goes in this hypothesis test. Let's see.
Would it be the 539 because they believed they would not have enough money?
No, no, no. Remember, 539 is the sample, right? You are surveying a sample of 1034 adults, and of that sample, 539 say that you won't have enough money. So in hypothesis test, you never put in the sample values. It's something else that you put a more default value or a more kind of universal value in the hypothesis test.
Oh.
You think about it while I'll just quickly take a call. Okay, so did you find the keyword or not? So, I mean, you have to look at in the question part of the problem where they are asking you.
Does the sample evidence suggest that a majority of adults, so we would put the number of adults?
No.
I don't know.
It's just one word. No matter what the context is, that one word will tell you what number to put.
Sample?
So, what word comes into mind when you think of sample? I mean, what number comes into mind when you think of that?
Uh, the let me see what yours is.
Okay, read
The
all the words.
1034.
What?
The
Read.
1034.
1034 is not a word.
But that's the number. When I think
Yeah.
sample.
And I just told you that the sample numbers are never put in the hypothesis test.
Oh.
That's why I said read the question part of the problem. Look at all the words in that question part and decide if those number if every one of those words invokes a number in your mind or not.
Mm,
So see, the question part of the problem doesn't even have a number in it, does it?
no.
Okay, so start reading every word of it and tell me which word invokes a number in your mind.
Country?
So what number comes in your mind when you read country?
Uh,
Oh, I'm loving it.
um,
And you will get there because there are only so many words in that sentence, right?
yeah.
So, so yeah, well, what number did you think of when you think of country?
Mm, I don't know.
No?
Yeah, I don't know.
It's so funny why you're trying to avoid that word. You're reading everything on this side and that side of that word, but you're missing that word again and again. Hmm. Reagan, what did you have?
I was wondering if you got my email from last week
Oh, yeah, yeah,
for
yeah.
stat.
About the 403?
Yes, sir.
Yeah, I did. I mean, the thing is, that there is no extra work, but like one thing I will do in that course is that if somebody is trying their best and putting in a lot of effort, then the curve will be pretty generous.
Um, okay. I've been trying like really hard on these quizzes,
Yeah, but
and
sometimes I see that you don't even spend enough time. Like it's a 2 hour quiz, and you in one of the quizzes I saw that you didn't even spend 1 hour on it, and it was a 2 hour thing.
yeah, that I was trying to do that one really fast because I had a class before it or a
I mean,
class right after it,
but I guess you have
and
to plan that better. The quiz stays open for a week. You can't say that, oh, you had a class before and after. You should have taken it at a time when you had more time. I mean, it's
I thought it was a like 2 day open for the
oh yeah,
quizzes.
okay, even if it's open for 2 days. But what I meant was, like a week before that, okay, it's going to be 2 days, and I mean, it's a big window. It's almost a 36 to 40 hours window. Don't you think you should plan it a bit better as to when to
Oh,
take it?
yes, sir. I've been doing that for like most of these quizzes, and I was just trying to see if like there's a possibility of me passing with a C.
Well, I mean, it's hard to say at this point, but all I can say is that there will be quite a generous curve if um, if someone is putting in the effort, because
Okay.
I know it's a difficult course. So
Mhm.
I mean,
I'm just really trying to make sure
it's even
I
possible that
get it.
someone with a 62 or 63% may get a C. It's quite possible.
Okay. Well,
Hmm.
thank you.
Okay. So no, still didn't figure out?
I have no idea.
What about this word majority?
Majority.
So mathematically, what does majority mean?
Hmm.
What percentage are we talking about when we talk of majority?
Not everybody, but like a good bit of people. I don't know. Would it be the people that believe they would not have enough money? I
Okay,
struggle.
let's say it's a class of 40 students, right? And
Okay.
I'm trying to get the opinion about something. So I say that, okay, um, there are 40 students in the class. Let's say there are 40 students besides you. So including you, there are 41, right? So let's take you out and say there are 40 students other than Haley. And when will we say that a majority of students like Haley? What number will decide that a majority likes you out of the 40 students?
Would it be half of them?
Well, if it's 20 and 20, then it's like half and half.
Yeah.
Then can I say that majority? No, probably not.
Like everybody but one person. You could say the majority.
Is that what majority means? What about if 21 like you and 19 don't? Isn't that majority liking you?
Yeah, because it's over half.
Yeah. So, so doesn't majority invoke the 50% in your mind, that anything over 50% is majority?
I mean, I didn't think about it that way, but
But do you think now?
yeah.
Okay, good. So I've taught you some English. Okay. That'd be the same as you one day teaching me something about math, which I don't know.
That probably would never happen.
Well, if I can teach a native speaker the meaning of an English word.
But I still don't know. Will we put 50 as the number?
So you have to put the percentage. So P is for percentage or proportion. So 50% is what? How do you write 50% as a decimal?
Oh, so we would put like 0.5.
Right. Mhm.
Okay.
And then what will come in H1?
Would it be less than because they will believe they will not have enough money?
Now you are investigating that does a majority believe or not? So you have to think of majority. Does majority mean greater than 50% or less than 50%?
Greater. So it'd be
Mhm.
okay.
Yeah, so it's not that not enough money. That's not what's deciding it. It's the word majority that's deciding what number. Mhm. Okay, and now
Um, would we use mm, I'm really not sure which one we would use to find the p-value because
why?
I don't
So what are the options?
um proportion stats, t-stats, and variance stats.
Okay, and
Which
then
I,
where do we look to decide which of the three?
mm, The question?
Or the hypothesis test. You can look at the hypothesis test.
Oh, why do I always forget?
Yeah, you
So
somehow you never want to look at this part.
no. So the P means we will use proportion stats.
So is it because of this big P or because of the little p here that we are using proportion stats?
The little p?
Yep, because the big P appears in all the three, but it's the
Right.
little
That's
p.
why I didn't know which one, because I thought maybe proportion stats, but then I was like, no, because you can find that in any of them.
Right, that happens in any of the. So it's only the hypothesis test which tells you which one.
Okay. I don't know why I never look at that.
Okay, so proportion test. But the good thing is that all these mistakes are gone when you take the tests, right?
Yes, hopefully.
Then
Cross
you're
them
a different person.
up.
But I think it's this practice that's good to make all the mistakes during the practice then.
Yes, for sure.
So
With summary.
summary.
And then now we will use those numbers, right?
Proportion sets. Let's see. One sample with summary. Which numbers?
The amount of adults and then the amount that believed.
Oh, yeah. Those numbers which you've been trying to use
Yeah,
for
I've
a
been trying.
while. So, what goes in the number of successes?
The 539
Mm-hmm.
and then the 1034 for observations. And then do greater than.
Oh, stop changing. Okay, greater than. Mm, 0.0856. So,
So let's see. That was 0.01. So this is great. The p-value is greater, so you will not reject it.
right. So, which one?
So let's see. It would be C.
Mm-hmm. Do not reject, and so there is not evidence.
Okay. Let's see. And I got mine right.
Good.
So I'm getting it a little better at least.
I hope you don't forget what majority means.
Me too. I'll be stuck on the test if that happens. Let's see. So that's the chi-squared symbol.
Right.
We'll use variance stats though, because up here in the hypothesis.
Okay. So stats, variance stats, one sample summary. Okay.
And we'll have to square
Square what?
for 1.4.
So that'd be 1.96.
sample size is the n.
So what goes in the hypothesis test?
It'll be less than and 2.2.
0.2?
2.2.
Really? 2.2?
Oh no. 2.2 squared.
Right, because the test is asking for square. 2.2 squared is 4.84. Okay, so 6.479 and the p-value is 0.018. 6.479. Okay, critical value.
That's when we use the calculator.
Which one?
We will use the chi-squared calculator.
Right. Zero one eight was the p-value. Stats calculated. Okay, and then what do I put?
The 1 minus n. So
And is the sign correct here of the inequality?
yes, less than.
Okay, and then
And then the alpha value will go over here.
area.
Yes.
Okay, so 7.962. And I'll once again ask you what your favorite criterion is once we get to the conclusion part. Okay, which graph is it?
C.
Which one? Say again.
C.
D? Really?
No, sir. C.
C. Yeah, because it's a smaller one which constitutes. Yeah, in a way, this is also a tail area. This is quite a big tail. Usually a tail is smaller, it's well before the peak rather than starting up to the peak. Okay, and then which criterion do you want to use, the P alpha or the other one? I guess in this case we'll have to use the other one because of the choices they're asking here.
Okay.
So now you go over it. Tell me what the things are that we do.
So in our graph,
Mhm.
that's where the critical value is.
Right, so the critical value was 7.962. So this is the critical value, okay. This is 7.962. And then what was the test statistic?
6.4.
Right, so this was 7.9 and this is 6.4. 7.9. So now tell me, where will 6.4 be compared to 7.9?
It will not be in the rejection area.
Really? You're telling me 6.4 will be on the right of 7.9?
Okay. It will be in the rejection area. I was thinking like it was a negative.
No, no. In chi-square, everything is positive.
Okay, so
This one will be 6.4 will be less than 7.9, so it will be in the area. So then, tell me which one.
would it be the second option?
Because chi naught was for critical value, no, chi naught was for test statistic, and this one was for critical. Okay, which one do we pick?
Um, would it be C?
C, right? Fallen means less than. Okay. Oh, here you don't have to do any stat crunch. You just have to answer concept questions.
So it says
So if the null is rejected, then what do we know about the evidence?
there's not sufficient evidence.
Oh, if it is rejected, then there is evidence. If it's not rejected, then there is not evidence. So they go together. If you do reject, then you do have evidence. And if you do not reject, then you do not have evidence. So in this case, it is rejected, so there is evidence. Okay. Oh, still more interpretation.
So how was it rejected?
They're telling us. I mean, suppose that.
Okay.
Yeah.
I don't know why that confused me.
Yeah,
Okay.
so we're not concluding anything here. They are just telling us the statements, and we just have to tell what they mean. Okay, so then more interpretation.
Okay, so
Was in fact the mean was 97.9. Okay, so this is related to the previous part. In part B, they are saying, suppose the sample data indicate that the null should be rejected. So if the null is rejected, it means you have rejected this one, right? This is the null. So if you have rejected this one, it means you are going by this one, right?
Right.
So this one is saying that the consumption has fallen below the 97.9. But now, what is this saying? Suppose, in fact, the mean consumption is 97.9, which is the null, right? Null was saying that
Right.
it is 97.9. Suppose the reality was that the null was true, that the consumption was 97.9, but you have rejected it. So have you made an error or not?
Yes.
Yes, you have made an error. And now the question is, have you made a type 1 error or type 2 error? So do you remember what those were, the type 1 and type 2 errors?
I remember seeing them. Let's see. Down somewhere. Let's see. Type 1 error would be the null true.
Keep saying, don't stop.
That's all I have. And then I have beta
Is that what you
2
got out
error.
of my video? The type 1 error is that the null is true. Oh my God. I said so much about type 1 and type.
Uh,
So you wrote a summary of what I said, but that summary lost the essence of what it really is. Okay.
oh, and here's the part about the square roots that I totally forgot about.
The variance and standard deviation thing.
Mm.
Okay. So type 1 error is that null is true, but you reject it. That's a type 1 error. I think you didn't write that part.
Yeah.
So null is true, but you reject it. That is type 1 error. And then tell me what should type 2 error be.
Um, I'm not sure which.
Well, so if type 1 says that null is true, but you reject it, the other error could be that null was not true, but you accepted it, right? So
Not true, but you accepted it.
yeah, so that's also an error. So now which one is this? Is this type 1 or type 2?
Type 1.
Type 1, yeah, because the null was true, but you rejected it and well went by the alternative. So that's type 1 error. So which one?
Um, would it be C?
Type 1 error because he accepted the alternative when the null was true. But what about A?
Yeah. It'd be A.
What's the difference between A and C, really?
One's talking about the alternative and one's not.
But let's test your English language skills. In essence, is there any difference between what's being said in A and what's being said in C? Let's put your English to test again.
A goes with like the definition. The definition doesn't say anything about the alternative. It's just talking about.
Right, very good. Yeah, that's talking like a statistician, right? Because otherwise, if you would read these two statements just out of this course, you would say that they're saying about the same thing, right?
Right.
But in statistics, we always talk from the point of view of the null, not the alternative, that whether you reject the null or whether you don't reject the null. So otherwise, English-wise, they are saying the same thing, but this is the statistical way of saying it.
And with B,
B.
would we put the mean consumption of fruit has fallen?
Oh, yeah. So which one?
So B.
B?
Yes.
Okay. Yeah. Did you say originally, did you say A or did I just mark A?
You just marked it.
Okay.
I don't think I've seen a question like this.
Yeah, I mean, you have seen them, but they're very rare. They don't appear much. And I think they came in 10.2.
Okay.
So here we have to find the sample size, right? What size sample should you use? So you know that normally in those stats, we do one sample with summary, and sometimes we do with data. But do you remember there are a couple of freak equations, freak situations when we use one of the other options also? So let me show you. So first of all, which stats do you think is it? Which of the three stats is it calling for?
Proportion.
Proportion, because why? Okay, estimate the proportion. Okay.
Yeah.
So now once you go to proportion stats, proportion stats, one sample. So now you know you have with data, with summary, and you have the other two things. Do you ever remember using any of the other two?
I feel like maybe width.
Yeah, with sample size. And see, you have to find sample size. So you have to use this one because this is the one. Okay, but the other one has power sample size, but we never use that, right? It's the width sample size. So now does this window look familiar?
No. Oh, yeah.
It does? Okay. So now we spot from this window that the sample size is what we have to find. So we have to know what the other three boxes are, right?
Right.
So tell me what goes in the other three boxes. So let's erase this one. This is the one that we are finding.
Okay. The confidence is 90, so 0.9.
Okay. Target proportion.
Would mm, would that be the 05?
No, that would be the 0.56.
Okay, since that's like what they're asking.
Right. So 0.56.
So the width would be the 05.
Why would the width be 0.05?
Mm,
Because that's the only other number in the problem.
yeah,
Is that how you reason in life?
yeah. Pretty much. And it says within that number, so
So,
width. I don't know.
so within is the same as width. Wow, wow. That's talking about when you say that trying to desperately say that width means the same thing as within. When you know deep inside your heart that the argument is not correct, but
Yeah.
you're just somehow trying to prove that it's correct.
Let's see.
So let's say I can guess your age within 2 years. So what am I trying to say? And so I'll make a statement like this, that okay, your age is 19 and my guess is accurate within 2 years. So what am I saying?
Um,
I'm saying that, okay, it's 19 plus minus 2. So I could be accurate within 2 years, like, so I'm not sure if it's 19, but if I say within 2, then I say, okay, it's between 17 and 21.
okay.
So what was that 2? That 2 was surely not the width, it was something else. And we do make statements like this in real life also, that, okay, I'm accurate within this much. So that should remind you of a term that we have studied in this course. And it's a three-word phrase, which that 2 was in this example that I gave you. Your age is 19 within 2 years. So what was that number 2 here? 3-word phrase.
I don't know.
Margin of error.
Margin of error.
Yeah, wasn't this 2 the margin of error that I was
Yeah.
saying? Yeah. So when they say within, it's within 0.05. So your margin of error is 0.05.
Okay.
Now the question is, I don't have a box for margin of error. I need what this width is. So is there a
Right.
relationship between width and margin of error?
I'm sure there is.
Don't trust me. Invoke your own knowledge.
Oh, I have no idea.
Okay. So do you agree that in this example that I was just giving about your age, 2 was the margin of error?
Yes.
Because I was like saying 19 plus minus 2. And then once I apply this margin of error, what interval your age could have been in? From where to where? So I was saying your age is 19 plus minus 2. So that indicates what range of your age, from where to where it could be.
From 19 to 21, or are you just adding
19
2?
to 21 or 17 to 21?
Oh, the -2.
Yeah.
Okay.
So you agree? So that error, margin of error of 2 years gives the interval 17 to 21 for your age, right?
Right.
So what's the width of this interval, the 17 to 21? How wide is this interval? How many years does it cover?
5.
Really? Isn't it 4?
17 to 21.
Yeah, how long does it take for you to go from age 17 to age 21? How many years does it take?
1.
It takes 1 year to go from 17 to 21?
Oh, I was thinking 17 to 18.
That's 17 to 21.
Okay, so it would be 4.
4, yeah. So the margin of error was 2, and the interval width was 4. So what's the relationship between the margin of error and the interval width?
We just added 2. I don't know.
Actually, okay, let's look at another. Let's say margin of error was 3. So, okay, I'm saying your age is 19 with a margin of error 3. So now what interval am I talking about your age? (19 plus minus 3). So tell me the range now.
Wouldn't it be 16 to 22?
Right. And how much is the length of this interval, 16 to 22?
Um, 6.
6. So the margin of error was 3 and the interval length was 6. So now do you spot the relation between the two? Previously, when it was 2, it was 4. Now when it's 3,
You multiply it by itself?
multiply by itself or multiply by 2?
By 2.
Right. So the interval length is always twice the margin of error. So now tell me, what's the width of the interval here?
Would it be 10?
0.10, right?
Right.
2 times 0.05, so 0.1. And now you compute.
Do my class, you scared me.
267.
Let's see.
Now, what do we do with this direction, which they say round up to the nearest integer?
We would just round it up to a whole number.
Well, this is also something I was explaining in the videos that this direction actually relates to pre-stat crunch era, where if you do it by a formula, which is a pretty long way of doing it, then you will get a decimal and then you have to round it up. But with StatCrunch, you don't have to look at this direction. StatCrunch does the rounding for you. Right?
Oh, okay.
So,
Right.
so you just ignore that. So you get 267. So now what do I do for part B?
It says she does not use any prior estimates.
So if you don't have any prior estimate, then the default target proportion is 0.5.
Okay.
Because that's a fair assumption that you are 50-50, right?
Right.
And now, does that mean we just change it to 0.5 and leave everything the way it is?
No, we'll have to change the width back to
During this
0.1.
process, the width has been disturbed.
Right.
So this is not what we had put in originally. So we change it back to what we had put it. To 71. So is this the only time we use this option of the width sample size when we have to find the sample size, or was there another kind of problem also in which we used it?
Mm, I feel like maybe there was another one as well.
And in that problem, they were asking you for the margin of error. So there also you have to do this one. And in that case, the n will be given. So if we look at the screen, so if you have to find the margin of error, then also you will know this, you will know this. And in that case, the n will be given to you. So let's say you have n as 54. And then you need the margin of error, but this will give you the width. So it says the width is 0.2238. So how will you translate this width into margin of error?
Um, mm, you wouldn't multiply it by 2
So the picture
because
is like this. So then what would you do? So this whole is the width of the interval. And margin of error is actually only half of the interval length. So now if you have the width, how will you find the margin of error?
Um, if you have the width, would you divide it
By?
by 2?
Oh, another one requiring the number of subjects, which means you have to find the sample size. Like it.
So would we do, I know we would use the mean.
So, which stats do we use when we are talking about the mean?
Um, T-stats.
So now tell me, what do I do?
Will we go to the width / sample size?
Yep. Stats, T-stats, one sample, with sample size. Okay, so tell me the values.
Okay. The confidence is 99.
Okay.
Mm, Would it be standard deviation?
Yeah.
17.5.
And now, with your improved knowledge of the width and the margin of error, what goes in for the width?
For the width, would it be 4?
Why?
The 2, and then you would,
The within 2 means the margin of error is 2, right?
right, you would multiply by 2 to get the width.
Yep. 512. Now,
Uh,
What's different in the second part?
I was trying to figure out what I did wrong.
Huh. What were your values?
$99
Uh-huh.
and then 15.9
Okay.
and it would be 8
Because,
4 times 2.
okay. And then what did you get?
A crazy number. Let me try that.
Are you the correct?
Okay, I
Are
think
you
I know what I did.
what?
Let me see if this is right. Yeah, in the width, instead of just putting 8, I
Uh-huh.
put 0.08.
Oh, no, 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 no. That's already incorporated in the thing.
Okay.
So you just put 8.
Yeah, I got like a crazy number. It was a big number.
Uh-huh. Now you get a more.
Yeah, I knew that couldn't be right. Okay. So now we'll just change the confidence level and we'll change the width back.
Good. So how does decrease in confidence affect the sample size?
Um, it decreases it,
Okay.
and decreasing the confidence level decreases the sample size.
Okay. A.
Yes. Um, okay, so we'll use variance stats
Right.
with data.
Because.
It was asking for the standard deviation.
Okay. Construct a 90% confidence interval for the population standard deviations, right? Variance stats. Open this. Stats. Variance stats, one sample with data. Okay.
With the data we get, how do we know?
Oh. How do we know the hypothesis test? Okay, so say the second part of your sentence. How do we know what?
Like which one to select?
What do you mean? What do you mean which one to select?
Like A, B, C. I thought you did the confidence. That's what I did.
Oh, okay, okay. So
And
90.
it's 90.
Okay. So what was the answer? So you get some answer, right? Okay, so now you're asking which of these three is it, right?
Right.
So first of all,
Like the characters.
wouldn't it be this one? There's a 90% confidence that a population standard deviation is between this and this. That's what confidence interval tells us. It tells us that the population value may lie between this and this.
Okay.
So
And then
put the values. Oh, oh. So are these the values? 62.9.
yeah, that's what I got. Something like that.
Do you remember something we mentioned a while ago? What are we doing for? Are we doing the interval for variance or standard deviation?
Standard deviation.
And variance stats give you
Variance.
variance. So how do we change it to standard deviation?
We'll do the square root.
Right. So you take the square root of these numbers. What's the square root of 62 point?
Would you do the square root of them to 3 decimals or would you do it to all of them?
Mm. So if the answer, well, if the final answer is needed to 3 decimal places, then it's a bit safe to do 1 decimal place more for the intermediate answer. So maybe you can do 4 places for the intermediate answers. $62.9559. Seven- 7.934 for the first one. And then
Ooh, I got it wrong.
you got it wrong.
Mm.
Let's see if I get it right. 270.758. Square root of 270.758. And then we look at your screen. 16.455. Okay. Uh, do you want to share your screen?
Okay, I got it right that time.
Okay, good.
The first time I did like all the whole thing, and the second time I just did to 4 after the decimal.
No. That shouldn't have gotten wrong.
Well, I got it wrong somehow.
No, did you look at, were the answers any different when you do all the decimals and versus you do all the four? So tell me, the numbers would be still there. No, you were trying to change my concept of mathematics. So, so tell me what your numbers were, original numbers before square root.
Let's see. Before the square root,
Yeah, when you said you did all of it, so what was the all of it?
the first one was 42.120057.
Okay, and what was the square root of it?
I'll have to do it again. Yeah, I think it was this first one that I got wrong because the correct answer is 6.49,
Yeah,
but the decimal is 6.4899.
yeah, but
So
that rounds to 6.490.
yeah, that's what I put in
That
the first time.
Yeah, so
I don't.
that is right.
Okay. Well, I don't know how I got it wrong. Maybe it was the second one.
Maybe you didn't round correctly.
Yeah, maybe I didn't.
No, it wasn't the fault of. In fact, you can never go wrong by selecting all of them, but you are even right by selecting just four of them.
Yeah, I must have just rounded it wrong. That's probably what I did. I think that was the last one.
Yeah. So for the final exam, you know that oh, there will be two brief reviews.
Okay.
And the brief reviews, of course, don't capture all the final because the final will be about 45 problems, and um, the brief reviews together only make about 25 or so problems. And so that's why I put a big final review as well.
Some of that pulled pork heated up in there.
Okay, I'm doing my class. Sorry.
So I put a big final review as well, which will not be for grade, but actually that is an assignment which captures all the final exam.
Okay.
And so, I mean, some students choose to do it because they think that's the real review for the final exam, but some don't do it because it's not for grade. so,
Right.
so now it's up to you if you. Um, so I guess a lot of students' destiny will be in your hands whether you.
I will probably do it for sure
Okay.
because I'll need it.
All right.
But since that was all,
Okay.
hope you have a good day.
You too.
And I'm sure I'll see you again before the final for that review.
Yeah, sure. It would be very sad not to see you again.
Yes. Well, have a good day. Thank you again.
Bye.
Bye.